All right. Express myself to the people who are watching YouTube on around February, I don't know, 23rd. You should have gone to lecture. Good job to the people who did show up. So say again? There's gotta be a sign-up sheet. It happened automatically because you need the sign-up. So yeah, like we do where it's like first the calc midterm and then the RFP and so on. But it is what it is right now. So as promised, kind of just a little bit more about what the midterm is going to be like. Look at the past midterm. There's a variety of school with ESC is a little bit I will there is so hopefully, I was muted the whole time. To repeat my hilarious joke, if you're watching this on February 26th before the midterm, well, should have thought about coming to lecture. Okay. So yeah, so it's going to be quite similar. There will be more short questions than there were in 2023. With that said, there will also be one or two questions that are longer. So for that, really what you want to do is you want to be able to do the labs and the project from scratch. So it's okay to get help. That's why the TAs are there. But ideally, you would be in a situation where you can say, okay, I understand everything that they needed to understand in order to do project one. And now I can do it by myself without help and without kind of just doing kind of shotgun debugging. So referring to just like trying to fix things without thinking them through necessarily. So like I understand the logical structure, all of it. So that's the outcome that you should be looking for after you have finished project one, which I assume everyone here already did anyway, but if not. So there will be, I'm in Vancouver for reading week, but there will be like remote help sessions and stuff. Maybe if some of the TAs are on campus, maybe we'll do something on campus as well. I would say that kind of the reason that what I posted is like 23, 21, 12, 11 is that those are kind of as close to what I'm doing with 190 out of, all the whatever this course has been taught, I believe, for like 25 years or something like that. So there is a lot of variation. So this course, it used to be that 180 was in C. Well, that's kind of as far as I know the history. So 180 was in C, and then 190 was actually in C++. And then in 2010, sorry, actually. So I taught the first version of 180 in Python, and then it was like Python and then 190 in C. With that said, there were a lot of instructors in 190, and different people took it in quite different directions, as you can see if you look at past midterms. Yeah.
Are your VC in Python?
Say again?
Well, are your VC in Python? They will both be on the test.
That's a good question. So there would be Python to the extent that Python was covered in this course. So Python was covered in this course in the first lecture, if you recall. And Python was Python was mentioned in the context of comparing the C memory model to the Python memory model. So we haven't really done, extensive output prediction with Python, I don't believe. So that would not be on the midterm. Generally understanding kind of how C structures can imitate Python integers, for example, is something that we've actually devoted quite a bit of time to. All right. Yeah.
Will there be any multiple choice questions?
No, I don't like. It makes no sense. I don't like those. So okay. Other questions? All right. I kind of gave you vague plans. I think that's like about kind of like 2023, but with more short questions is, I think, the best way of putting it. So there are shorter questions in 2012, 2011. So 2012, 2011 is not my midterms. It's written by another colleague. So focus on 2023, 2021. With that said, 2021 was a special situation where it was written online during COVID. So obviously there is like some differences there. And then 2023, I think, was not supposed to be different from 2024, but it turned out, I think, to be more difficult than I was aiming at. Yeah.
When you say the code actually had to compile, so when we write our handwritten solutions,
I mean, like, it's like 180, right? Like, yeah. The general philosophy is, if it's a very short question, then okay, like you're missing a semicolon. Well, we got to ding you for that because like it's a short question. There's like 20 characters in total. You got one wrong. Well, that's got to be at least 5% off. So possibly more. On the other hand, if you're writing something like Q5 and you forget the semicolon, of course we don't care, right? So don't kind of stress over it. With that said, like obviously kind of try to write correct code as much as possible. So not anything that's different from 180. So when I was referring to code actually having to compile in 2021, it's just that it was submitted on Gradescope and there was an autograder. So in that sense, it had to compile, because if it didn't compile, then the autograder couldn't run. So we still actually did give partial marks as well. So we went over the questions manually too. But of course, kind of the bulk, or not the bulk, but like 60%, I believe, or something like that was autograded. All right. Yeah. No. If you just read the front page, it wouldn't be that different. So we mark on correctness.
Last term you said this term we would care more about comments.
Did I? Well, if I don't know what I was saying. I changed my mind. I don't know what to tell. So you will not be you will not be graded on read. So in general, I kind of moved. So I used to grade homework on code readability, and I stopped because it was so subjective that like they were like, like half the class would then come to me and say, like, I disagree with the TA. And like half the time that happened, they looked and said, okay, like you have a point. And at that point, well, like someone didn't complain because they just accepted what the TA said. And there's genuine differences between what different people consider to be kind of optimal code. So I just gave up grading on that. By the way, I don't know, I think I announced it at some point. So if you go to the 180 grade scope, we gave everyone who should have gotten feedback on the project 3 code. So you can look at that. So that's not graded. It's just kind of feedback for like how you could write it better. So all right. So correctness, of course, just like with 180, it might be that we'll say it's got to be a certain computational complexity. That's completely legitimate. That's not readability. With that said, if we don't say it has to be this efficient, then you can, as long as it runs and like finishes running before the heat death of the universe, you're good. Okay. Okay, all right. So what I want to do today is link. So one more thing. So people asked me about textbooks. So there is a bit of an issue with textbooks for 190, which is that the textbooks that exist are either more kind of at the level of 180 or more at the 200 level. So for that reason, I don't really follow any particular textbook closely. With that said, for people who want to read something, what I would suggest is the King textbook. So the King textbook is what we used to use in ESC180 when ESC180 was taught in C. So it tries to start really from the ground up. But like maybe like, especially if you feel like you're behind, maybe like just like from the ground up, assuming you don't know any programming at all, we'll teach you programming and we'll teach you C. Maybe that's exactly what you want. So check it out. It's not for everyone, but I think it's a good option, and it basically goes up to what we'll actually do today. So up to linked lists. So that's one option. So then this is really because kind of Kernighan is an Anxi grad. I don't think it's necessarily good as an introductory textbook. And then this Kiana book would be relevant in the second half of the semester. All right. So what to read from King? Well, on the one hand, it's a quite thick book. On the other hand, like I said, like literally it goes up to linked lists, which is today. So obviously it goes into more detail than what we do in lecture. So in lecture, we focus a lot on kind of designing something efficient, stuff like that. King really tries to give you like every little detail about the C programming language. You don't need to know every little detail about the C programming language. You need to know how pointers work, how functions work. You know how functions work for 180. So really you need to know how pointers work and how structs work. And that's all that we've done, right? With that said, and like include, define, stuff like that we've also done. So let me make a list. So stuff that I think everyone is familiar with. So that would be functions, and that would be conditionals, and that would be loops. And then stuff that's new to you from 180 would be structs and, of course, pointers. And stuff that's not hard, but you want to know is define, if, and include. And that's, I believe, it, right? So that's the syntax that you need to know. I think really kind of all of those except for pointers are just not difficult. So, you know, like you take maybe like, especially if you did the labs, you don't even need to take the hour to review. But I think everything except pointers is like an hour. And then, of course, pointers is like the rules are pretty straightforward. Of course, applying the rules is a different thing. All right. So, okay. All right. So I want to start linked lists. So what are linked lists? So basically it's a way to store in a linear fashion. That's silly. So a way to store lists without pre-allocating blocks of memory. Right? So what we've seen up to now, this is a bit dark. Okay. So what we've seen up to now was basically you say in C, right? Unlike in Python, you say I'll pre-allocate a block of memory and then I'll just put stuff in there, right? And then if I need a larger list, I'll reallocate. So an alternative way is to say, okay, so pictorially people represent it kind of like this. So I'll have those are called nodes. And then what I'll have in every node is I'll have some data there. And then I'll just say the next data point is stored in the next node in B. And then I can just add stuff to this chain. So if I want to append, I'll append like this. So for now, this is just represented pictorially. If I want to insert, I'll just say, well, now C, for example, is going to point to something else. So C is going to point to X, and then X is going to point back to D. And this one we break. Okay, so that's kind of the idea. So you have this kind of chain of data, and each node is hooked up to the next. Okay, so let's now define it to be more concrete about it. So I'll define a node struct. And it'll have data and it'll have a pointer to the next node. Like this, right? So the idea is that each of those guys is a node. So it has a data point and it also has the address of the next node. Is that making sense? So now let's set something up. So we'll have a nicer way of doing that in a second. But for now, I just want to set up a simple linked list. So I'm going to say, okay, so node head is going to be like this, and I'll malloc some space for it. And then I'll put some data in it. So note that now that head is actually pointing to an address where I can store the struct, now I can say head arrow data is equal to 1, right? So before I could not. So if I try to do something like that, don't copy this. So if I try to do something like this would not make sense because head right now is just nothing. So you cannot say go to a random address head and then inside of data and that address put something because that address is not valid. But after you've allocated head, so now head is an address of an actual thing, you can say, go to that thing and set the data to 1. So now I'll allocate N2. So that's the same thing. And I'll put whatever, a 5 there. And I'll say that head next is N2. So the structure that's implied by this is we start with head, and then we go. So unfortunately, like this is a different arrow, so that might be an unfortunate clash of notation, right? But we have head, but that's how people write it. So we have head, and then head is hooked up to N2. And head contains 1, and N2 contains 5. Is that making sense? Yeah.
In general, when you create a struct, do you always have to malloc it?
That's a good question. So do you have to malloc the instance of the structure that we've defined here? And the answer is, well, usually you would, but strictly speaking, you can also say something like node A, right? So if you say something like node A and then whatever, A data equals 123, that is also valid, right? So that is saying I want a local variable A. It doesn't matter what VS Code thinks. It's just, I don't know why it's underlying everything, actually. Expected. No, this is fine. I don't care what it thinks. So I mean, that's the malloc, but that doesn't explain everything else. So I think it's no. So node undefined. I misspelled type def is the problem. Okay, now it's all good. Yes. So you can say node A and then A.data 123, or you can do this, right? So both of those work. The difference is that, like this is a local variable. I can return it if I wanted to. But in general, when we write a create node thing in the same way that we had a create by end thing, it's more usual to pass a pointer and then set the value at that pointer to something that's mallocked rather than do something like this. What you do want to avoid is mixing both of those styles together, because if you mix those styles together, then you don't know which variables you need to free and which you don't need to free, because you cannot do free address of A. Right? So free address of A would cause the program to crash. This is indeed bad. If you tried free of A, that would not even compile. Right. So in summary, this is legitimate. This is also legitimate. You just need to keep track of what style you chose to go with. This is the more usual thing. Make sense? If you do this, then this is definitely not legitimate. Because you cannot free something that wasn't mallocked. On the other hand, if something was mallocked, then you do need to free it, or there is a memory leak. So let's in fact free. Well, once we're done, we'll free head and we'll free N2. Okay, so coming back to this. So this is the structure now. So what's convenient here is I can now choose to insert N3, right? So So how would I do it? So what I want to do is I want to create a new node that's going to be N10, let's say. And that's going to have the value 10. And what I will want to do is I will want to hook up the N1 to N10, and I'll want to hook up the N10 to N2, and then disconnect this. Does that make sense? So how would I do that? I'll create a new one. And now I'll just say, okay, so head next used to be N2. I now want head next to be N10. So I'll say head next is N10. And then I'll say N10 next is N2. So several things here. So one, I mentioned that I want to disconnect 1 from 5. Well, that happens automatically, right? Because it used to be that head next was N2. And then I just said, well, head next is N10 now. So one way of thinking about it is there used to be a connection between head and N2. And then I just said, well, instead of head next being N2, I'm making head next be N10. Does that make sense? So then I said, I also want a connection between N10 and N2. So that is how I accomplished it. So the other thing is, let's review the pointer arithmetic again here. So the interesting things start happening here. So here I'm saying head next is N2. So N2 is of type node star, meaning address of node. And head next is also of type node star. Here, by the way, you have to say struct node star. You cannot just say node. And that's just because while you are defining line 18, you still haven't gotten to line 19, so it doesn't know that it's called node yet, so you have to call it by its full official name, struct node. Okay? So next is of type struct node star, aka node star once node has been type def. So that means that this makes sense. The right-hand side is of type node star. The left-hand side is also of type node star. So that's why it's N2 and not star N2, not address of N2, not anything like that, just N2, because N2 is of type node star. So thinking about it, so this is kind of thinking about it at the syntax level, right? So like, the units have to match. Thinking about that in terms of what's actually in there, well, what I want to do is inside head, I want to store two things. So I want to store the actual data, so 1. And I want to say, if I need the next node, where do I find it? And the answer is, well, at address next. Right? So when I'm creating, for example, N2, I'm saying, give me an address where I can store N2. And then at that address, put a 5. And then head is going to keep track of the next data point is at that address. Right? So it's a little bit like a scavenger hunt, right? So you if people know what that is. So basically, you know, like you go to one room, in that room, it says, like, here's what you're looking for in this room. And here is a note that says to which room to go next to get the next thing. Right? So that's what's going on here. Is that making sense? Questions? All right. So, okay. So what I want to do now is, now that we kind of have set it up, I want to write some functions that are kind of more organized than this. So I'll do a create linked list. So here, what should I send here? So if I want to create it from just scratch, I need to send the address of head so that I can put an actual address in the pointer head once I've populated it. And then I'll send it some initial data and I'll say how much. So now, okay, this is actually not, oh, no, this is right. I was going to say that Copilot screwed up, but I don't think it did. So, okay, so now in here, I'll just create my own local head. So that's the same as before. I'm just saying head is malloced like this. Actually, before that, I'll say that if the size is 0, then I'll just set head to null and I'll return. I'm done. I don't need to malloc anything. Right. So now what I'll do is I'll create my local head and I'll just start populating stuff. So head data is going to be data 0. And the head is going to be head. So I'll just rename this to current, just because that would be more convenient. So what I did now is I created one node and I stored data 0 in that node. So now what I want to do is I want to keep creating nodes and keep sticking them at the end of the linked list. So I'll start with I equals 1 because I equals 0 is already taken care of. And I smaller than size, I plus plus. So now what I'll do is I'll create a new node. And Copilot is suggesting a clever way of doing it. So what I'll do is I'll malloc and put the address at node next. Right? So I'm not putting it at current yet, I'm putting it at current next. So what that does is it says, make a node on the fly and set the address of this new node to current next, so that current next is already hooked up to the next node. So now that it's malloced, I can put the data there. And now that I'm done with this, I'll say, okay, so current is now current next. So what happens is I start with head. And then I say, okay, so head next is this new thing. I'll call it A, whatever. I'll set current next data. So I'll set the data in A. And then I'll say, okay, the current is now A, so I can do it again. And then next time I'll put a B there or something. So, okay, so once I'm done, another subtlety here is I need to know when I'm done. Just like with a string, I need to know when the string is ended. I could, in principle, just have a separate integer. It's the integer that keeps track of it. But another option is to just say the linked list is done when the next is null. And that's it. So the reason null here is underlined really is because I did not include stdlib. Okay, so let's do a simpler thing. So let's say that I just want to print out the linked list. So that would just get the head. And here, what I'm going to do is I'm going to say, okay, so print head data 0, and then just make head be the next node. It doesn't matter that it's still called head. So let me quickly write it. So I'm saying print this, print an arrow. Like this. Right, so what's going on here? So let me just copy and paste this so that it's closer together. So what I'm saying is I get the address of the first node, and I'm saying print the data at that node. Once that's printed, head, which is just a local variable, make head be now the next node. Again, at the syntax level, head next is of type node star. Head is of type node star, so those match. Basically, what I'm saying is that head is always the node we're currently printing. Right, so we're first printing out the actual head, and then we say, okay, we printed out head, so just advance head to the next node, and then print that, and then advance head to the next node, and then print it. So specifically, it's like the address. So again, thinking about like you're going from room to room and you're printing the contents of the room, and then there's a note in the room that says which room to go next. So head is that note with a T, which says like, this is the current room. This is the address of the current room. And then you just copy the next address to that node and you say, okay, now I'll go there. Is that making sense? So, okay. So why head not equal null? Well, because basically, when head is equal to null, that means that we've reached the end of the linked list, right? So if at some point the next is null, that means that we've reached the final node of the linked list, and we stop right when it's null. Of course, if the address is null, you cannot go to null arrow data. So that would just crash. And it works out because we never go to null arrow data, because if head is equal to null, we just stop the loop. Okay. So that's printing a linked list. Let's do an insert. So what do we need to do? So we need to find the node that's before the index and put a new node in there. So one issue is, what if index is 0, right? 0, so index 0 means we need to insert before the current head. So that kind of suggests that we need to be able to change the head. Right? So let's treat this as a special case because it really is. So we'll say if index is 0, so we create a new node. We put the data in that node. And we say that the next after this new node is the head. So node star p head, because we sent the address of the head to the function. So to get the address of the node, we need to star so that it's of type node star. And now the new p head is gonna be new. Okay. So else what we need to do is we need to basically go through the linked list until node I-1, and then insert the new node after I-1. So, okay. So the current is gonna be the head. So note that here it's again star p head because we sent the address of head. So if we actually want the current one, it's gonna be just star p head. And now we're just gonna go up until node index -1. So we keep updating current, right? So current is, we just keep track of like, here's the address of the node that we're currently looking at. And first we look at star p head, and then we look at star p head next, star p head next, and so on. So now that we found the right location, we'll create the new node. Could have done it. So we are doing it twice, so might as well do it outside. Just so that we don't repeat the same thing twice. And now we're going to say, okay, so new next is going to be current next. So the picture is over, sorry. So the picture is over here. So we are inserting the X. If we are currently at C, we're saying, okay, so D used to be C next, but now we want D to be X next. Is that making sense? Yeah.
I smaller than index.
No, it's supposed to be I smaller than index -1 because we want to go up to node I-1, not up to node I. So we want to advance I int -1 times. So, okay. So now we say, okay, so current next is equal to new. And that is because, again, so current is, sorry, where's my picture? So current is C. and we want C next. It used to be D, and now C next is going to be X. Is that making sense? And that's it. So just quickly, I have 2 minutes before reading week begins, for us at least. So why are we doing all this? Like, what's the point of this? Well, the point is, if you have a very long list, then inserting the way we've done with the arrays that, not arrays, memory blocks that got reallocated, is if you insert at the very beginning, that means that you must move a whole bunch of elements one spot to the right. That's the complexity of that is O of n. If you have n elements, you got to move all of them. Here, at least if you know where you want to insert, which granted insert L does not, it has to go through the list in order to do that. Here, it's not like that, right? So here you can just do surgery on the list and just like rearrange the nexts. And that just happens locally. You don't need to move a whole lot of elements in order to do that. So this is not a supernatural example here because insert L is also O of n because of this thing. Because if you know that you want to insert at index I, well, you got to go through the list. However, in about a week's time, you'll see an example where it so happens that that's not an issue and insertion really is of 1 because you keep track of where you might like to insert. Okay. So with reallocated block of memory, it doesn't matter if you know where you want to insert, right? Like if you want to insert, you need to move a whole bunch of elements. Here, if you know the location, then you're fine. It's an O1 operation to insert in the middle. So, all right, okay. There will be an announcement about online sessions. Enjoy, not the break, like the process of writing the RFP, whatever it is that you do during the reading week. Okay, I'll see you. Bye.